This problem can be done very similarly to some of the other problems where we're being asked to factor, where you can throw this cubic into a calculator and try to find at least one zero value. The thing to note on this one is that if I wanted to, I could actually see all of these different zero values on the calculator screen, which means that I actually could use that to fully factor this. Since this coefficient is a 1, I know that once this is factored, it's going to be all just x for each of my linear factors. So I don't have to adjust a coefficient or anything. And so I'm going to have a linear factor that corresponds to each of these zeros. So I could actually do this as simply as that. The other thing to remember is that if I, for example, didn't have 3, I could do exactly what I was doing in the earlier ones, where I take the one that I know, and then I could set, one that I know up with synthetic division and reduce that down to a constant by factoring. I don't know why I said reduce that down to a constant. I meant divide out the factor. So I divide out x plus 1 using synthetic division with -1, and I'm left with x squared minus 3x minus 10. At that point, I always recommend trying to factor the quadratic first, and in this case, we can factor it as x minus 5 times x plus 2. But again, just being able to see on the calculator that those 3 are all exactly zeros is enough that I should be able to just factor from that.